right, so we've got to talk about literal equations real quick, and I don't know if you've done these before. You probably have. You've at least probably seen some of them before. But literal equations are equations that are comprised mostly of variables. So, do y'all know like a squared plus b squared equals c squared? Yes. What is that?
No, it's
Starts with a P. Somebody said it. Pythagorean theorem. Y'all, that's a literal equation because it's just got variables in there. Normally we plug stuff in for the variables and you solve, okay? But today you're just dealing with those equations, so there's just the variables in there, and generally not too many numbers. So if it's just an equation, how do you think you would solve it? Is it going to be like worlds different from how we solve regular equations?
No,
It's going to be exactly the same. Exactly. So it's all the same except you've got letters now, okay? So you solve them exactly the same way as regular equations. So we're going to look at our first example here. So we've got ax plus b equals c. So now for some people it's very confusing to have all those letters going on. So what I want to do is replace those letters with numbers because we're good with numbers, right? If there's numbers in there, we're good at solving for x. So give me a number that you want to put in place of a.
4.
So we've got 4x plus in place of b. Give me something. Anything. 2. And something for c.
8. 4.
Let's do 10. That okay? So we're just picking random numbers to plug in place there, okay? So it wants us to solve this for x, so we're going to do the same thing over here. What would you need to do first? Minus 2, yeah?
Yeah.
So what was in the same place as 2 over here?
B.
So what do you think your first step is over here?
B.
Minus b, right? Does that make sense? So we'll come back and do that in a second. So we've got 4x equals 10 minus 2. Are those like terms?
No, let's see.
Can we do 10 minus 2?
Yeah.
Yeah, what is 10 minus 2?
8.
8. Then what do we do from there?
Divide by 4.
Divide by 4. So what does x equal?
2.
2. Cool. So we know how to solve equations like that, yeah? So same idea over here. Like we said earlier, what was in the place of the 2? B. So your first step is going to be to do what?
Minus B.
Minus b. Now here's where it gets a little bit different. Are c and b like terms?
No.
So can we combine them?
No.
So what do you think we need to write?
Need to write
C minus b. Can't do anything with it, so just leave it written out. So after we subtracted 2 over here, what did we do next?
divided by 4.
So what's kind of in the same place as 4 over here?
A.
So what do you think we need to do?
Yeah, divide by A.
Divide by a. So x is going to equal, are c, b, or a any of those like terms? So is there anything we can do with this stuff?
No.
No, so just rewrite it. C minus b all divided by a. And that would be your final answer there. Is that okay? So we've got some steps on the other side where we're going to write out what we just did. So the first thing that we did was we moved the b, and the opposite of addition was subtraction. That's why we subtracted it. Then next we moved the a. So the opposite of multiplication was division. I'm not going to write that out because I'll spell it wrong. And then you were solving for x, and that was what we had all by itself, so we were good to go there. Questions?
No.
Is anybody like super confused yet?
So,
So what are we not sure about? Yeah.
you just, so you make up the numbers and you copy it
You can. That's one way to do it.
That's what you're trying to say.
Yeah.
Copy what you did.
So like if it was a regular equation, we would know how to solve it, right? So if you need to substitute numbers in for everything except for the variable that you're solving, you can do that. And then just go back and follow the steps that you did.
But you could just do
We
it
can
without substituting.
just do it, which is what we're going to do this time. Is that okay?
Cool.
All right, so looking at the next one, we've got a equals 1/2 times base times height. What is that? What formula is that?
Oh, that's
Triangle.
no.
What of a triangle?
Volume.
Area.
Oh, base times height is something. No, area is like not area. Volume is like something. What is it?
Would be like base times height times like width. You
Yeah.
have to have the whole, all of it, the whole box. So we want to solve for h. So we want to get h all by itself. I'm going to highlight that. I think it's easier sometimes, especially if you leave all the variables in there, just so we know what it is that you're trying to get by itself. So what do we not want over there?
The 1/2.
We don't want a 1/2. What else do we not want?
The B.
The b. So I want to get rid of the b first, just because that's the stuff that's going in over here. So how can we move the b?
Divide. B.
How do we know to divide that b?
Because it's multiplied.
It's multiplying. When everything is touching like that, there's no signs in between. That means multiplication. So are a and b like terms?
No.
Is there anything we can do with that?
No.
No, so we're going to have a over b equals 1/2 h. How could we get rid of the 1/2?
You gotta
Add 1/2. Divide over.
divide.
It's 1/2, like times h, right? So you can move it, you could divide by 1/2, or what else can we do?
Add over.
Nope. When you divide by fractions, what are you really doing? Multiply by the reciprocal, or just the denominator in this case, because it's just 1/2. If it was like 3/4, you'd have to multiply by 4/3. That's that reciprocal flipping it. So that's what's supposed to go in this blank over here. So moves 1/2 by multiplying multiply, multiplying by the reciprocal recip.
Wait.
That just means flip it. So we're gonna flip 1/2. What do you get? 2/1. So just multiply each side by 2, which is what we do to get rid of fractions anyway, right? You multiply by the denominator. So that 1/2 and 2 cancel out. Then we're going to have 2a over b equals h, and that's your final answer. 2a all over b equals h. Multiplying by the reciprocal, sorry. I didn't know what you were talking about. So what are we thinking? Do we like plugging in numbers and solving it that way than comparing, or are we good to just
I
solve?
think it's easier plugging in numbers just because you know you can.
Is it okay if we do a couple more like that? Would that be helpful? Can y'all like listen and pay attention and tell me? Because I can't help you if you don't give me anything back. Yeah, do more like that? Okay. So 1 through 8, pick one, anyone, I don't care.
8.
8. Okay, we can do that. So we want to get b by itself. So you want to plug in numbers? We think that's easier.
Yeah.
All right. Actually, can we not do 8? That was gonna be messy. Can we do 4?
Yeah.
Let's do 4. Okay, so we're solving for 8, yeah? So I'm gonna go ahead and highlight A so I know what we're trying to get by itself. All right, so let's pick some numbers, any numbers. What do you want to put in place of R? Somebody said 1? 4. Okay, then we got 3A. We'll leave that because we want to solve for A. Then you have plus 5C, so what's something that we could put in place of C?
2.
Okay, cool. So y'all, we just made these numbers up, so our answer's probably not going to come out to be anything like nice and neat. So when we get a fraction, don't freak out. So what will we need to do first here?
The times 5.
5 times 2, what do you get?
10.
10. So can we go ahead and just minus 10 from each side?
Yeah.
So what is 4 minus 10? Negative 6 equals 3a. This is going to come out nicely. How cool. What should we do from there?
3a divided. No, 3 divided by 3. No, 3a divided by 3. There you go.
So we're dividing by whatever's in front of a. So negative 6 divided by 3, what do you get? Negative 2 is our answer there. So we're going to use those steps that we did to help us look back and figure out how to solve this equation for a. So what was the first thing that we did? I don't
We
remember
did
how to do
5
this.
times c.
Well, we did 5 times c, and it's just 5c. So is there anything that we can do with that? No, so we won't worry about it. What did we do next? We did minus 10. What's kind of in the same place as minus 10?
5c.
5c. So what do you think we need to do?
Minus.
Minus 5c. So r and 5c, are they like terms?
No.
Is there anything we can combine there or simplify it? Nope, so we'll just leave it. R minus 5c equals 3a. So when we had just 3a on this side, how did we get a by itself? What did we do?
We divided by 3.
So what do you think we need to do over here?
Divide by 3.
So divide by 3. Will any of this stuff simplify? No, so we can just leave it a equals r minus 5c all over 3. And that would be your final answer there. Is that okay? Yeah? We'll do number 8 now, but I'm not going to plug numbers in place of anything there. So we want just b by itself. So what are we thinking? What can we move that's not even touching b? Ax? Yeah? So we could say what? Plus ax minus ax divided by ax times ax. Trent, what do you think? We said we got to move the AX. That's what we said, Will. You were talking to Evan. Okay. So what do we need to do from here? We want to move the AX. So how would we do that? Somebody help him out. What do we need to do?
We gotta.
Oh, you need that.
How are we going to move this AX? Subtract it. Why?
Because it has.
It's positive. And it's like it's being combined with that other term. So you just got to move it to the other side. So C and AX. Do we have any like terms there? Is there anything we can combine or simplify? So how are we going to write it out?
C subtract AX.
C minus AX. Yeah. Nothing else you can do there. That okay? All right. What's our last step there? We want X all by itself. Or no, what do we want? B, sorry. We want B all by itself. What do we have to get rid of? We got to get rid of X. What else?
Negative.
Can we just divide by a negative X? Will that take care of both in one step? Yeah, let's do that then. So the negatives cancel, the X's cancel, and we have B equals. Now there's a couple different ways that you could write your answer here, so I'm going to show you both. We could leave it just as it is right there, so C minus AX over negative X. Or, have y'all like broken it up so you divide everything by the denominator? Do y'all know what I'm talking about with that? So what you can do is break that up so that it's C over negative X minus AX over negative X. Does that make sense? So it's the same denominator, we just split it into two separate things, with this being our numerator for one of them and this being our numerator for the other. Yeah? Do you see what I did here?
Yep.
Okay, so c over negative x, will that simplify it all? C and x, they're not like terms, right? So we could just leave that part the same. So we'd have negative c over x. Then what about right here? Negative over negative does what?
It cancels off the negative.
Cancels negative, so we have plus something. X over x, what's going to happen?
Going,
Cancel each other.
yeah, cancel.
Cancels each other out, so you're just left with what over here?
Hey,
A. So both of these things are the same. Is that okay?
So you'll always accept those.
Yep. So either way is fine. If you just want to leave it here, I totally understand. I will take that 110%. That is A-okay with me. If you want to take it a step further, that's awesome. Go ahead and do that. If you're concerned you may mess up, so you just want to leave it here, I'm good with that.
if you write both, then we get extra credit.
No.
Dang.
Is that okay? Are we all right still?
Yeah.
Let's do you want to do like one or two more together?
Yeah.
Are y'all like experts?
Dude, no, we need to do number 5.
Okay, that's the one I was looking at. Let's do number 5. All right, so we want to solve for D. So that's this guy right here. We want to get D all by itself. So this is one where it would be pretty simple to plug stuff in, like plug in numbers for everything but D. If you wanted to, you could do that. You don't have to. I want to do it without it just so that we like all know how, because it's not always easy. Like for number 8, that one would have been very messy. So if you've got a big fraction, how do we get rid of it?
You gotta multiply
Multiply by what?
the number.
So what's in our denominator?
2.
So we're multiplying both sides by what?
No.
So 2 times q, what is that? 2q. And then over here, those 2's cancel. What drops down?
C plus D.
C plus d. So again, we are solving for d. So we want d all by itself. What do we still need to get rid of?
C.
C.
So how are you going to move that c? Trent, this is time for redemption. How are we going to move that c? Yeah. So 2q and c, are those like terms? Can we combine them? Anything we can do there? So how are we going to write it?
2x equals negative c.
What?
X. Wait. What?
2q, what? Subtract.
Oh, c. Wait, ain't that what I just said?
You were throwing x's in there. We don't have any x's, my friend.
Oh.
Oops, I kind of cut through that. Oh well.
I'll say
Is it starting to make a little bit more sense?
Yeah.
Yeah? Do we want to do some more?
Do number 2.
Number 2?
Yeah. No, knock out all the
All right, we'll do number 2. This will be the last one, then we'll do the rest on your own. So for number 2, we want to solve for t. This one's a little bit tricky because the variable that we're solving for is in the denominator. So this is different, right? How do you get rid of fractions? We still want to get rid of that fraction, right?
You gotta multiply. But
So
that-
multiply by what?
Yeah, it's messed up. You can't multiply by 2 because that's what you're trying to do. You gotta multiply by
But we got to get rid of that fraction. So let's do that anyway and see if that helps, okay?
Can't mess it up.
So we're going to multiply by what to get rid of the fraction?
T.
T, because whatever's in your denominator. So those cancel out. We'll have 3k drop down on the right side. And then t times v, what do you get?
TV.
It's tv.
And then you go by 5.
So we're solving for t, right? So what do we have to get rid of now?
Divide by B.
Divide by v.
And then V.
So 3k and v. Are there any like terms? Can we simplify? Anything you can do there? So t equals 3k over v. But okay.
Yeah.
Questions? Do we need to do any more together?
It's all good.
Number 5? We did number 5. Is that okay? Any others we want to do? So we got 1, 3, 6, and 7.
Go 7. Do 7. Do 7.
Oh, yeah.
7? Ooh, yeah, we do need to talk about that one. Because what's going on right there?
It's a pi, man.
Pi. Ooh, pi. Does anybody know what pi stands for?
1.13.
3.14.
Oh, 3.14. I knew it was a
What's the
thing.
furthest that anybody can go?
3.14.
3.14, what?
Don't stop, man. You keep going.
7.
Oh, wait, somebody said it. What'd you say? Somebody said it. Or was saying something.
Evan, what'd you say?
3.14, what? 15?
9. 7. 6.
That's as far as I know.
Man,
And that's only because I did a race that was on that day. It was on 3/14/2015, and we started at 9:26. That's the only reason.
Wait, hold on.
Whoa.
My brain was like, man,
Yeah.
and right at the same time.
So wait, it started. You did a race.
It was on March 14th, 2015, and we started at 9:26 in the
How
morning.
do you know what time it started, man?
Because I was like on the planning committee.
What kind of race?
It was a pie day, Pi K, like a 5K. It was a Pi K.
That just ruined the whole story, man.
I was in math club in college. What do you
That
expect?
was a good story, and then you just. Dude.
Anyways, so we got a pie going on here. What are we trying to solve for?
You trying to solve for a
For what? For what? For what?
R.
For R. What are they doing to the R? What's happening there?
They're doing it by their exponent twice.
What is that called?
Radius.
What?
Radius.
Oh,
Wait. Exponent.
I learned something.
What does
It's
it mean?
you're squaring the R.
You're squaring the R, right? So
3.14 squared.
we're gonna have to come back to that in just a moment. So right now, what can we get rid of that's not even touching the R? Or well,
Hey.
we want to get R by itself. Everything is touching it. What do we have to get rid of?
Ah.
How are you gonna move it?
Subtract 3.14. 15, 9, 26.
Are we gonna add, subtract, multiply, divide?
Subtract, divide.
Five.
Why would we divide?
Oh, just like.
It's all be multiplied, yeah? So we're just gonna divide by pi. We're not gonna write out that big long number 3.1415926. We're not gonna worry about that. Okay, because we're just using that placeholder of pi, okay? So A divided by pi, can we do anything with that? No, so we'll just leave it A over pi. The pi's cancel out, what are you left with? R what?
R stands for like radius.
R does stand for radius in this problem, yep. R squared. Does anybody know what that formula is? Like backspace, just a second.
Wait, we learned about this. Listen.
A equals pi R squared.
Area.
It's on the back wall. It's really small on that one that says formulas, but it's back there. Should be back there, I think.
A equals R squared.
Area of a circle.
Area of a circle.
Area of a circle.
Because y'all, A always tells you what?
Area.
Area. If it's got a pi in there, it's probably talking about a circle.
Oh, and then R radius. Pooh.
Oh my goodness, making so many connections today. Alright, so R squared, is that what we want?
Yeah. No.
We just want R, right? How do you do the square root? That's how you undo a square root. Have y'all ever heard of that before?
Yes.
dude.
Awesome. So we're gonna square root each side. So can we take the square root of A over pi? Can we do that? No. So we'll just leave it a big square root of A over pi equals, what happens when you take the square root of R squared? What do you get?
It's R.
It's just R. So whatever was squared just drops out. Is that okay?
Yeah.
Questions?
Yeah.
Okay, so you've got 1, 3, and 6.
Is that homework?
I want you to do those right now. Can we do that? 6 minutes.
Wait,
That's like max. I'd really like you to have it done in 3. So stop talking and do 1, 3, and 6 right now. Go.
I'll be right there. I just got a brain fart.